Welcome to the distance learning program presented by Innobus on JAXP, that is Java API for XML processing. Let's see the introduction of JAXP. The Java API for XML processing is for processing XML data using applications written in Java programming language. JAXP leverages the parser standards simple API for XML parsing, which is called as SAX, and document object model, which is DOM, so that you can choose to parse your data as a stream of events or to build an object representation of it. JAXP also supports the extensible style sheet language transformations, which we call as XSLT standard, giving you control over the presentation of the data and enabling you to convert the data to other XML documents or to other formats such as HTML. JAXP also provides namespace support, allowing you to work with data type definitions that might otherwise have naming conflicts. In latest version, JAXP implements the streaming API for XML also, which generally termed as STAX for streaming API. Designed to be flexible, JAXP allows you to use any XML compliant parser from within your application. It does this with what is called as pluggability layer, which lets you plug in an implementation of SAX or DOM API. The pluggability layer also allows you to plug in an XSL processor, letting you to control how your XML data is displayed. JAXP enables applications to parse, transform, validate, and query XML documents using API. So this API is independent of a particular XML processor implementation. So JAXP doesn't do any kind of processing. Instead, it provides a mechanism to obtain parsed XML documents employing SAX, which we have already seen, that is simple API for XML, and DOM, document object model parsers. So it provides a mechanism to plug in with various providers. The libraries that define needed JAXP APIs are javax.xml.parsers, org.w3.com, and org.xml.sax. Finally, you have javax.xml.transform for parsing techniques. So let's see the one of the parser from JAXP, that is simple API for XML SAX. The simple API for XML is the event-driven serial access mechanism that does element by element processing of an XML. So the kinds of events can be the start of the document when it is encountered, end of the document, start tag of an element, end tag of an element, character data when it is encountered, a processing instruction when it is encountered. So these are the tag elements which can be found in XML document. So these events will be used by the simple API XML for processing. The API for this level reads and writes XML to a data repository or the web. For server-side and high performance applications, you will want to fully understand this level. But for many applications, a minimal understanding will suffice. So depending on that requirement, you can see the working of APIs for XML. So when to use simple API for XML processing? It is fast, efficient, but its event model makes it most useful for such state-independent filtering. So it is helpful to understand the SAC event model when you want to convert existing data into XML. So this is the simple API for XML. So here if you see, this is a basic outline for SAC's parsing APIs. So to start the process, an instance of the SAC's parser factory class is used to generate an instance of the parser. The parser wraps a SAC's reader object. When the parser parse method is invoked, the reader invokes one of the several callback methods implemented in the application. So those methods are defined by the interfaces like content handler, error handler, document type definition handler, and entity resolver. So we'll see all these interfaces in detail. So this is how the start process will begin in simple API for XML when instance is created by the SAC's parser factory class. And this is used to generate the instance of parser. So the parser wraps a SAC's reader object. So whenever there is a parse method invoked, the reader invokes one of the several callbacks, which we are going to see now in detail. SAC parser factory. So this is the factory API which is used for object creates an instance of the parser determined by the system property which is coming from package javax.xml.parsers.sacs parser factory. Then you have a parsers. The SACS parsers interface defines several kinds of parse methods. In general, you pass an XML data source and a default handler object to the parser, which processes the XML and invokes the appropriate methods in the handler object. SACS reader. The SACS reader wraps a SACS parser will wrap a SACS reader. So it is the SACS reader that carries on the conversation with the SAC event handler you define. Default handler. The default handler implements the content handler, error handler, document type definition handler, and entity resolver interfaces with null methods. So based on your requirement, you can select appropriate interface and override the methods to define your actions. Content handler. This interface also defines the methods, characters, and processing instruction which are invoked when the parser encounters the text in an XML element or an inline processing instruction respectively. Error handler. There are methods like error, fatal error, and warning which are invoked in response to various parsing errors. So the default error handler throws an exception for fatal errors and ignores the other errors. Document type definition handler. So this defines methods you will generally never be called upon to use. Used when processing a document type definition to recognize and act on declarations for an unparsed entity. Entity resolver. The resolver entity method is invoked when the parser must identify data identified by an URI. In most of the cases, an URI is simply a URL, Uniform Resource Locator, which specifies the location of a document, but in some cases, the document may be identified by an URL. So a public identifier or a name that is unique in the web space. So therefore, the public identifier may be specified in addition to the URL. So the entity resolver can then use the public identifier instead of URL to find the document for example, to access a local copy of a document if one exists. So those were the APIs used in simple API for XML, and these are the packages. Like there is an org.xml.sax which will define the interfaces of Sax. So the name org.xml is the package prefix that was settled on a group that was defined Sax API. So org.xml must be used for any of the Sax packages. Next you have an extension package that are used for doing more sophisticated and Sax processing. Like for example, to process a document type definition or to see the detailed syntax of a file. And there are helpers, contains helper classes that make it easier to use Sax, for example, by defining a default handler that has null methods for all the interfaces so that you can only need to override the ones you actually want to implement. Then there are parsers. So this will define the Sax parser factory class. So which returns the Sax parser, also define exception classes for reporting errors. The benefits of using Sax are simple API for XML consumes less memory. As it collects the information from the document as a single stream, therefore the entire document does not need to be loaded into a memory at once, allowing Sax to parse a file of any size. Sax has the advantage of fetching in small subset of information from a large document and is able to ignore unnecessary data. Sax makes it possible to get the required piece of information from a document as rapidly as possible. These are the benefits when you use simple API for XML for parsing your XML documents. There are also the drawbacks. When we use this, it does not support random access to the document. Like it can be difficult to use Sax on documents that contain many internal cross-references. So it does not provide lexical information, it is read-only. Now let's see the document object model. A document object model is a standard tree structure where each node contains one of the components from an XML structure. So the two most common types of nodes are element nodes and text nodes. Using DOM functions, it lets you to create nodes, remove nodes, change their contents and traverse the node hierarchy. There is another approach for parsing XML documents called document object model approach. So this is also one more approach used for parsing XML documents. So this is the document object model APIs. So here if you see, you use javax.xml.parser where the document builder factory class to get a document builder instance. And you see that instance to produce a document object that conforms to the document object model specification. The builder you get in fact is determined by the system property javax.xml.parsers.documentBuilderFactory. So which selects the factory implementation that is used to produce the builder. So the platform's default value can be overridden from the command line. You can also see that document builder, you can use a method called new document method to create an empty document that implements the org.w3c.com dom.document interface. So alternately, you can use one of the builder's parser methods to create documents from existing XML data. So there is a result of DOM tree which is shown, which is having object and nodes representing each node and object. Whenever you pass an XML data, using this document builder, you can build the XML with having nodes in it. So this is the package of document object model API. So here there is or.w3c.dom. So defines the DOM programming interfaces for XML documents as specified by W3C. javax.xml.parser, it defines the document builder factory class, and this class returns an object that implements the W3C document interface. So therefore this factory is used to create the builder determined by javax.xml.parser's system property, which we have seen that it can be set through command line. This package also defines parser's configuration exception class for reporting exceptions. Let's see the benefits. DOM API produces an in-memory tree-like version of an XML document as well as a number of methods for traversing the model and obtaining the data stored in it. As object-oriented, it gives an object structure to make changes in this model and passes these changes back to the XML document as output. This is also one of the usefulness of getting the object using object-oriented model. Now let's see the XML document structure. The XML recommendation states that an XML document has both logical and physical structure. Logically, an XML document consists of declaration, elements, comments, character references, and processing instructions, collectively known as markup. Physically, it is comprised of storage units called entities, each of which may refer to other entities, similar to the way that include works in C language. For example, they have given how the include works in C language. The same way, it is comprised of storage units called entities, which can in turn refer other entities. An XML document consists of three parts. Majorly, that is XML declaration, which is technically optional, but it is always recommended in most of the cases. An XML document type declaration that refers to an document type definition, which is again optional but required if you want validation. And body or document instance, so which is always required in your XML document. Collectively, the XML declaration and the document type declaration are called as XML prologue. So XML is a case sensitive. And if you see, this is the simple XML which is having declaration part, type declaration where you are declaring the document type definition declaration, and there is a body having any kind of HTML data in it. It can start with HTML with head, title, and body in it. So this represents the body declaration or body content of your XML. And this is the basic syntax of XML. Also to remember, it is a case sensitive, and also in declaration, the tag what you're seeing, the question mark, there should be no space there. And if you consider, for example, simple example, which the XML is defining the book detail. You have a books tag within which you have one book containing the author, the price of the book, and the publishing date of that book. So also it has got one more element within the books, that is publisher info, which can have child elements like publisher and the state of the publisher. So this is the typical XML which can have a declaration which we have seen, syntax, and this is the body content. And this is how XML document structure represent. using the nodes. So root element will be the document XML, that is books, and within which you have two elements, book and pub info. So this too will act as a parent for book, having child, author, price, and pub date, and publisher info will have child elements like publisher and state. So this is how the XML document structure will be built. The document object structure. At the top level, the XML document object has the following three entries. So we have seen XML root. This element will be the root element of your document. XML comment. This will be the string which made the concatenation of all the comments on the document. That is, comments in the document prologue and epilogue. This string does not include comments inside document elements. And also there is a doc type which gives the document type definition. So this entry only exists if the document specifies a doc type. The element structure. Each XML element has the following entries. You have XML name. The name of the element includes the namespace prefix, and within which you have a namespace prefix, the prefix of the namespace, URI of the namespace, and also the text, that is XML text, the string made up of concatenation of all text and C data text in the element. XML comment, XML attribute, where all this elements attributes as name value pairs. Finally, there is an XML children, all those element children elements, and also the parent XML node of type, the parent document object model node of this element. This entry does not appear when the CF dump tag displays an XML element structure. So XML nodes. So it is a type array, an array of all the XML node DOM nodes contained in this element. And finally, there is an XML DOM node structure. So this table represents the node structure where you have XML name, XML type, and XML value. So name, as said, the node name. Each node such as element or attributes. The node name is the element or attribute name. XML type, the node, XML DOM type such as element or text. And finally, the XML value, the node value. This entry is used only for attribute, C data, comment, and text type nodes. So all these of type string. So this was the detail on XML document structure. Let's see the demonstration on parsing technique using SAX, that is Simple API for XML. We have already seen the APIs used for Simple API for XML. There are many APIs used for parsing technique. Let's see a small demo on this. For parsing using programming, JDK, that is Java Development Kit, comes with default package which can be used for parsing techniques. So here we are going to see first demo on Simple API for XML parsing, which can be used for parsing XML. So we have also seen the XML document structure. So here consider there is an example with an XML file having this data, which is having the declaration part. We have seen this, and this, there should not be any space here when you are declaring the declaration part. And this is the root element of your XML, which we call as body declaration, and this will be the elements within that root element. And this is the end of your root element. So this is the basic XML file which we will be using for parsing using Simple API for XML parser. So this XML is used for it. So this XML is placed within this package. This is a Java package. So it's a simple Java package, that is Java project, and within which there is a package com.inobus, and we have a class called sax browser. So this is the class name within which main is present, static void main. So since the JAXP is all about for Java programming, so even the simple API for XML processing is also for Java program. So here we have a class with main method, and here there is a file which takes argument. So this is the argument values which will be passed to this main method, and this we are going to pass XML file as an argument. So the XML will be hello.xml, which we just now saw, and as sax parser factory, this is the main class or API, that is application programmer interface, which is used for creating new instance of sax parser factory, which in turn will give the parser, nothing but sax parser. So this is the parser which can have a parse method to parse the XML document. So once you get the instance of the sax parser factory, you're also getting an instance using new sax parser. So once the parser instance has got sax parser, you can use the parse method to scan or to parse the XML document, what we get through the argument. So therefore, apart from the XML source file, also there is a parameter which is taking the handler. So here default handler is used, which comes within a package of org.xml.sax.helpers. So this default handler will be provided by JDK, and we can make use of it. So here if you see, there is a class myContentHandler. So this return type will be the instance of default handler. Let's see what is there in this class. So there is another class myContentHandler, which in turn extends default handler. So here there are many methods to scan or parse the XML document. So we have all seen that simple API for XML parsing, that is sax, is event based parser. So it will fire the events when it is coming across the element of XML. So therefore the parser used will produces the events based on reading the XML document. So whenever it finds start document, this method will be invoked. So whenever it is having end document, this method will be invoked. So based on the event, there are methods defined: start document, end document, and start element for starting of the XML element, end element for ending of the XML element, and characters when characters are parsed, when characters are encountered. So these are the main methods which are used. Here I have used simple string, which can have an underscore as a string, just to signify the root element and child element. So here when we meet start document, so it will come start document as a println statement. So once start element it encounters the start element event, it will read all the attributes. So attributes are the XML element attributes which will be read. So here the element will be printed with the name, and the attributes will be iterated through the for loop, and the number of attributes will be printed accordingly. So I have used sysout statements. So all the attributes within the XML statement will be printed. And this end element, so first of when we have this sub element, it will be replaced with double I underscore. So whenever it will be end element, it will be single underscore. So we'll just see whenever we also see the character encountered within an XML element, it will be prefixed with C. So these character strings are just to show that this is the beginning of element, end of the element. So these are not necessary, but in order to show this demo and make it more clear, I have added all these characters to show this is the character which has encountered, and this is the start element, end element for element for XML element, and attribute for A. So these signifies the events for XML data. So let's execute this program. So this is the return type which we get the instance of this as a default and the instance, and this instance will be passed for the parse method. So therefore the parse method coming from sax parser will take the source, which will be the XML file, and then the handler to handle the events when we come across the XML elements. So let's run the main program, that is sax browser. So when you run this as Java application, you also need to see when you are also giving the argument, because main is taking an argument array. So therefore, if you see in this argument, there is hello.xml. This is how we pass the arguments through XML. So this argument will be taken by public static void main and then used as a source for parse method. So this is how we pass the argument. Here hello.xml is the XML file. So once we have run and executed, you can see here it has started the document. So we can compare this with the XML file. You will know starting the document, after which when it has come across the start element, so this is the start of the element. It is prefixed with E. And what is the element name? It is user. So if you see the my handler processing, we are printing the element name. So this will be the parameter where string element will be giving you, that is start element, and that will be printed element. And once you have this attribute, the attribute, here we have only one attribute for this user element. There can be many. So here when it has come across one attribute, it has also printed as attribute prefixed with A. It is showing you that this is an attribute with attribute name and attribute value. And how is this processed? It is processed within start element method, where it is getting the attribute parameter. So here if you see, there is an attribute parameter for the start element method. So this attribute is coming from or xml.sax.attributes, and this will give the attributes of your XML. And here when we have many attributes, we can iterate through a for loop. So attribute.getLength will give 1 in this example, and accordingly it will print the attribute name, that is this attribute name and attribute value. So once it has printed this status active, the next was character encountered, which will be blank or double quote. So after which there it is coming across first element XML, that is first name. So here it is again prefixed with XML element, telling it is an element, and then that element name is first name followed with character. So when it has encountered the character data, this is the character data event. So therefore it is printing character name. So for the same processing, it is also done for next element. So if you see, there is a next element coming across here, E, that is last name, and also it is encountering a character data event and printing you the last name as Smith. Finally, it has encountered a character. The space can be a character or it can be any character. It has encountered one character, and finally it is ending the element. By seeing this, it is telling it has encountered ending the document. So this was the starting document which has encountered here and ending the document. So this is the simple parsing technique provided by Simple API for XML. So we have seen all the APIs used, where it starts with sax parser factory by giving the instance, within which it is giving the instance of sax parser, and we parse the XML document using parse method provided by sax parser. So here we have seen the XML structure as well as the handler. Your default handler is used. The class is extending default handler, so within which you can also override the methods of that class having start element, end element, and then start document, end document, and characters. So this is how the parsing is done for simple API for XML processing. Let's see the parsing technique using DOM, that is Document Object Model. And before knowing the parsing technique demonstration, there is important to know that we get the return types, that is node types, when the XML is parsed using Document Object Model. So these are the values. If it is an element node, the value of node type is 1. If it is attribute node, it will be node type of 2. If it is text node, it will be node type of 3. And if it is character data section node, it will be of 4. For entity reference node, it will be 5. And entity node, 6. And processing instruction node, 7. Comment node, 8. Document node, 9. Document type node, 10. Document fragment node, 11, and finally notation node, 12. So these are the node types that are supported by Document Object Model. So now let's see the demonstration on parsing technique using Document Object Model. So let's see the demonstration on Document Object Model. So here there is a project that is simple Java project having source folder within which there is a package, and inside that there is a single file, and we are going to parse the file, that is XML file, using simple elements having root element as user and child elements as first name and last name with values. So let's see how this parsing technique is done using Document Object Model. We have already seen the APIs, so we'll be using the same APIs. There is a class name we have given as DOM browser. So in Document Object Model, there is an API class called Document Builder Factory. So we have already seen this. So the instance of this will give the factory, and this factory in turn will give an instance of Document Builder class. Using Document Builder instance, parse method can be used to parse the XML file. So here it is taking the XML file coming from the argument. So we are going to pass for this Java application as argument parameter. The file name of XML will be passed as argument parameter. So that will be passed using this parse method of Document Builder. So for any of the parsing technique, there should be a factory which can be used to get the respective API class instance, and finally the parse method which is going to parse XML document. So after parsing, we are trying to print the document. So let's see how this document will be parsed. So finally we are printing this to see the output. So here we are considering the node and getting all the child nodes, which will return the child nodes in terms of node list, and the attributes of the node, which will be in terms of name node mac, and finally printing all those respectively. So the node in XML document we have already seen will be the node name, which is nothing but the root element name, and node type, the type of that node, and node value. So finally it will be iterated for all the elements in the XML and printed. So this is the simple demonstration on DOM parsing technique. Let's see the output. run this Java file as run on Java application. Before that, you can also see the argument which has been passed. So hello.xml has been passed as an argument for this Java application, and then click on run. So once you have executed this, you can see this output. So it has encountered document node. This is of type 9, which is nothing but document type. We have already seen the node values, list of node values supported by document object model. And this one, it tells 1 because it has got child element 1, and then -1, no attributes in it. And then user element is coming across, and here it is 1. It's a root element, and it is of type 5. It is entity reference node, and it is having one attribute, one child, and entity reference node, which is of 5 value and having one child. And what is that? One attribute. This is the attribute, and that attribute was status. So status in turn has got 2, which is telling the attribute node is of type 2, and this is having one child and no attribute. And again it is coming across the text. What is the text? Active. So that is text. This is of type text. Node is of text, and it has got no child and no attribute. So we'll see, compare and see with XML file, you can understand better. So here if you see, so here it is coming across the document object at the beginning, and this is the document of type. And next is the root, that is document, which has have one child with of 5, which is telling entity reference node. And this is the attribute because it has got attribute in it. So value of it is 1, which is telling it has got one attribute. And further is followed is the status of type text node. So this is of type text node, it is 2, and 1, it is telling it has got one child, which is nothing but active. And finally it has got no attribute, so it is -1. And next it is processing active, where it is the text node, and this is the attribute of type attribute node. And then this is of text node, which has got 0 child, and then -1 is no attribute in it, and what is the value is active. And finally this is again the text node, no child, no attribute, ending with that. And next element it is coming across is first name of type 1, which has got and one child with 0 attribute, and that child is John. And next is text node, which is nothing but John, and here it is 0 child and 0 attribute, so that is -1. And what is the value of that text node? It is John, and it is getting ended. And again it's the same thing for last name. So here it has got one child, last name element, that is Smith, and in next line it is printing it is of type text node, having 0 child and no attributes, and the value of that text is Smith. So this is how XML parsing is done using document object model. So if you want to see the class again, we can see here. So beginning of API is document builder factory, then document builder, through which we get the method called parse. Finally, using this document instance, you can get the node within which we have many methods, get child nodes, get attributes, and using these methods we'll print the node type, node name, as well as node value. These are the methods from document object model API classes, using which we can parse the element and know the type and name of it. And this was the simple demo on parsing technique done using document object model. Here we come to the end of this training. Thank you.